Hey guys, I want to do a quick lesson for you. Well, as quick as it can be, actually. We're going to look at section 6.4 and let's do a quick introduction here. Alright, so we have this equation, y equals x squared minus 4x minus 1. And here's its graph. I'm showing you early. We want to find these two roots. Okay, we want to find out what the x value is when y equals 0, or the x-intercepts. So we can do this a few ways. Let's go ahead and do quadratic equation. I think you're used to that a little bit. If this is a 1, -4, and -1, you get x equals negative b plus or minus the square root of, let's do discriminant on the outside, b squared minus 4ac, which is 16 plus 4, which is 20. So the square root of 20 all over 2 times a. X equals 4 plus or minus, this is 2 root 5, the square root of 4 times the square root of 5. So 2 root 5 all over 2. So that means x equals 4, reduce that, that'll be x equals 2 plus or minus the square root of 5. I divided 4 by 2 and I divided 2 root 5 by 2. So here's our solution. Now, here's what I want to do with this. I want you to understand that these are two different solutions. X equals 2 plus root 5. And x equals 2 minus root 5. And what I did was I took the liberty, I went into calculator, and this is the square root of 5. The square root of 5 is about 2.236 whatever. So if I do 2 plus the square root of 5, I'm getting a number that's about 4.2. So you can see right here, well actually if I erase those, you can see that this number is about 4, see, 1, 2, 3, 4.2, which makes sense. So this one's 2 plus root 5 right there. And this one over here, if this is 2, here's minus 2.2, minus 1, 2, and 0.2 right there. This one's 2 minus root 5. So what you really want to see there, and by the way, this number's 2. So what you really want to see is from your vertex, you create this distance. From 2, you go plus root 5, and here you go minus root 5 over. So from your vertex, you see those distances. These are corresponding points in that they reflect right across the axis of symmetry at x equals 2. So again, this is how far over it goes from your vertex to hit your x-intercept. So it's the same both ways. And this will always happen. Even if this wasn't a square root, you're still getting the same distance away from your vertex. Remember, this part's all negative b over 2a, and this is the distance away from there. So what I'm going to do with that is make sure that you understand that this plus or minus thing always occurs with irrational numbers, like these radicals, and with imaginary numbers. So we're going to learn two theorems right now. One's called the irrational root theorem. Okay, and this is straight out of your book. We have two numbers a and b. They're both rational numbers. The square root of b will be irrational, meaning this is not a perfect square. So if a plus the square root of b is the root of your equation, meaning, remember when we said find the roots? If this is one of your roots, let's do that different color. If this is one of your roots, a plus root b, then take a look at this one, a minus root b. If a plus root b is one of your roots of your equation that has rational coefficients, then the conjugate of a plus root b is a minus root b. That one will also be a root. So let me try and make sure I get that hammered home here. I had rational coefficients, 1, -4, and -1. How do I get rational numbers when my answers are irrational, is the question. And the answer is they have to be conjugates, a plus root b, a minus root b. Because if we played around with this a little bit, okay, what if I do a plus root b times a minus root b? You might have seen me do it before with complex conjugates. This is kind of a difference of two squares. You get a squared minus a root b plus a root b minus the square root of b squared. So this becomes a squared. These two get canceled out, and the square root of b squared is b, so that's minus b. So the whole thing I'm taking home with this is that these are both rational numbers. Okay? when you do this multiplication, you end up getting rational numbers. You eliminate all your irrationals. So that's the cool thing about this, is you can have real number coefficients and still have irrational numbers. So here's an example. If you have a polynomial equation with integer coefficients, so meaning that, 1, -4, -1, for instance. So if this polynomial equation has the roots 1 plus root 3 and negative square root of 11, we need 2 additional roots to this thing. Which means here's one answer to your x-intercept, 1 plus root 3. If that's one of them, this must be another, 1 minus root 3. Because one of your answers in your things has to be x equals 1 plus or minus the square root of 3. That just happens when you do quadratic equation and you have irrational numbers. Same thing here. If you have x equals negative square root of 11, that's x equals 0 minus the square root of 11. Well, then there has to be x equals 0 plus the square root of 11. Right? Plus or minus the square root of 11, or the square root of 11. Because one of your other solutions is x equals plus or minus the square root of 11. Okay. So your two answers that we're actually looking for, the two additional roots are x equals 1 minus root 3, and x equals square root of 11 right there. That's an example, and we'll go over it more in class. I just wanted you to see one example of it, and we'll be able to multiply this out, and you'll see exactly how that cleans up. Okay, imaginary root theorem. Now, I've actually talked about this one before, but let's make sure the examples come in play for the same exact reasons. If you have a complex number here, or we have a plus bi with that complex number, and it's a root of a polynomial equation with real coefficients, then the conjugate a minus bi is also a root. So if you think about when we did things like simplification, you have the number 2 over 3 plus I. The way to get rid of the imaginary numbers on the bottom was to multiply by 3 minus I over 3 minus I. And the reason we did that was because on the bottom, 3 plus I times 3 minus I equals 9 minus 3I plus 3I minus I squared, which is 9 plus 1. Remember, these cancel, and negative I squared is negative 1, so minus negative 1 is plus 1, so you get 10. Okay, and so that's just an example of why that works and why that's true. So again, it's just a take-home message there that we do. Okay, they say find a third degree polynomial, meaning it's an x cubed polynomial, with rational coefficients that has roots 3 and 1 plus I. So that means your answers, there are going to be three answers. There's x equals 3, there's x equals 1 plus I, and there's also going to be x equals something else. Now, if a plus bi is a root, like 1 plus I, then a minus bi also has to be a root, 1 minus I. Okay? So this one has to be 1 minus I. If that's the case, check this out. We need to actually find the polynomial, though. So that means x minus 3 equals 0. X minus 1 minus I equals 0. I subtracted these over. And x minus 1 plus I equals 0. Which means, when expanded, it looks like, I can't write it. It looks like this. Okay? So let's go ahead and take this, and let's start distributing as soon as we write this as a polynomial. So if this equals 0, that means we're trying to write an equation. So this has to be y equals this guy right here. Okay, I'm going to leave x minus 3 alone, and I want to take care of these first here. Let's use a box so you know exactly where I'm going with this. It'll be a 3 by 3. Okay, we'll have x minus 1 minus I and x minus 1 plus I. Okay, we get x squared minus x minus ix. Then we get minus x plus 1 plus I, and then we get plus ix minus I and minus I squared. Okay, what you'll see here are items that cancel out. Minus ix and plus ix, they're gone. Minus I and plus I, they're gone. Negative I squared is positive 1, so I'm going to change that to a 1. Okay, and let's see what we got. So that's y equals x minus 3 times, this became x squared. Check this out. Minus 2x, negative x, minus 2x, and plus 1, this becomes plus 2. So see, the whole benefit of this thing having imaginary roots, although it can have them, is that there's a conjugate that exists that cancels out all your imaginary numbers. And so now we can do the rest here. I'm actually not going to use the box this time for the sake of diversity. X times x squared, that's x cubed. X times negative 2x is negative 2x squared. X times 2 is 2x, then negative 3x squared, plus 6x minus 6. So your final equation is y equals x cubed minus 5x squared, combining like terms, plus 8x minus 6. So this is the third degree polynomial. This is the third degree polynomial equation. This has all rational coefficients, 1, negative 5, 8, and negative 6. And the roots are 3, 1 plus I, and 1 minus I. And notice how that cleaned up afterward. Okay, now we're going to do some stuff here, and you actually see the answer down here. This is the thing you'll remember, and you'll see why. I'm going to do this one with long division, and then we'll do difference of two cubes with synthetic division. Okay, we're going to do a cubed plus b cubed, and a plus b is actually a factor. Let's prove that and make sure that's correct here. Okay, so with a long division here, we're going to do a cubed plus b cubed. Now you'll notice here that I don't have to leave space, but you'll notice what's going to happen here. It's not going to come out exactly alike. There are terms in between, just like, there's an a cubed, somewhere there's an a squared, and somewhere there's an a to the first, and somewhere there's an a to the 0 power, which is your constant right here. I'm going to check every time. I'm going to check and see how many times a goes into my values, just like I would x. Okay, so a goes into a cubed, a squared times. So you're left with a times a squared is a cubed, b times a squared is a squared b. We got to subtract. A cubed minus a cubed is 0. 0 minus a squared b is negative a squared b. I'm going to bring down my, well, I don't have to bring down my b cubed yet, but I might as well. Plus b cubed. How many times does a plus b? How many times does a go into negative a squared? Well, it goes in negative a squared b, sorry. Negative a squared b. So the question is, a times what is negative a squared b? Well, it's negative a b. See, a times negative ab is negative a squared b. B times negative ab is negative ab squared. This is 0. 0 minus negative ab squared is positive ab squared. Bring down the plus b cubed. How many times does a go into ab squared? The answer is b squared. You multiply a by b squared, you get ab squared. So a times b squared is ab squared. B times b squared is b cubed. And you subtract to get 0 as a remainder. So this guy is your quotient when you divide a cubed plus b cubed with a plus b. Do I expect you to fully get that? Well, sort of. I really expect you to know how to combine like terms and do long division. So I need this to be understood. But the idea is I want to prove and show you that a cubed divided by a plus b is that. So there's this thing called the sum of two cubes. If you remember the difference of two squares, there was a reason why we had that property. Here's another one, the sum of two cubes, a cubed plus b cubed. It can factor out to that. Okay. Now how do we double check that? We can do a plus b times a squared minus ab plus b squared. Let's actually distribute that. We get a cubed minus a squared b plus ab squared plus a squared b minus ab squared plus b cubed. Negative a squared b, positive a squared b cancel out. Positive ab squared, negative ab squared cancel out. You're left with a cubed plus b cubed. So double check, we did division and we did multiplication and we got the same thing. So the whole idea is we can factor this kind of guy into this if we need to. And this will be important because then we can get a quadratic, which we can use quadratic formula for. Okay, here is difference of two cubes. I'll do the same thing, only this time I'm going to do synthetic division. this will be a little more different. Here I have a minus b. This is a linear factor. If a minus b equals 0, then a equals b. So b is one of your roots here. So when we do this synthetic division, we're going to use b up in here. And our coefficients, you have to remember that a cubed minus b cubed is a cubed plus 0a squared b plus 0ab squared minus b cubed. Okay, so your coefficients here are, this is 1ab cubed, 1, 0, 0, and negative b cubed right there. Okay? Remember, treat a as your variable. B is just a constant. That's why I have a negative b cubed that exists. 1 plus nothing is 1. B times 1 is b. There. B times, add, you get b right here. B times b is b squared. You add, you get b squared. B times b squared is b cubed. Negative b cubed plus b cubed is 0. So here's your remainder. And then you're left with this stuff. Now remember, a is your variable, kind of like x. So instead of making these x's, I'll make them a's. So this is remainder, constant, linear term. This would be like bx. I'm going to put the a there. And your quadratic term, a squared. So this is what it divides to. Again, if you understand synthetic division, then this might make sense to you. And thus gets your difference of 2 cubes right here. So you can see we divided this by a minus b, and we got this as a result. So here's your difference of 2 cubes. A cubed minus b cubed equals a minus b there times a squared plus ab plus b squared right there. Okay. Again, I'm only going through the division so you see why it exists. Not necessarily something that's very easy for you to do. I just need to make sure that you understand that it's there. And yeah, there's that. So I'll just give you an example of why we're doing it before I sign off here. Let's say we had, let's do 8x cubed minus, let's go 64. Okay. The idea behind this is that you have an a cubed. The cube root of this is 2x quantity cubed. So the cube root of 64 is 4. So here's your a value, and here's your b value. So we can simplify this. This reduces to a minus b times a squared plus ab plus b squared. That becomes, I can actually factor out a 2 from here as well. So this becomes 2 times x minus 2 times 4x squared plus 8x plus 16. And notice I can factor a 4 out of here as well. So that becomes 8, 4 times 2, times x minus 2 times x squared plus 2x plus 4. And the whole idea behind this, again, is what if this was an equation right here, a polynomial equation? You wanted to solve for the x and y intercepts, or I guess the x intercepts. You set this equal to 0, and you have to figure all the rest out. I know that x equals 2. If this is all equal to 0, then I know that x equals 2 is one of my roots, and I know that this is one of my roots as well. And you definitely have to use quadratic formula or completing the square to figure out the rest. Because I still have 5 more minutes, I'm going to give that one to you. Do x squared plus 2x equals negative 4. I'm going to complete the square on this one. X squared plus 2x plus 1 equals negative 4 plus 1. Right? Divide by 2 and square it. This becomes x plus 1, quantity squared. This becomes negative 3. Take the square root of both sides. You get x plus 1 equals plus or minus I root 3. So x equals negative 1 plus or minus I root 3. So your 3 roots here are 2, negative 1 plus I root 3, and negative 1 minus I root 3. So again, you'll see we started off with something that had real coefficients, 8 and negative 64. We had to go to difference of 2 cubes right here, factor that out, pull out this 8. Remember, this 8 had nothing to do with when this equals 0 here. And we went all the way down. We got our solutions here. I don't expect you to understand this immediately, but I expect us to be able to transition into this more easily instead of you being fully bombarded with new stuff right off the bat. So that's all I got for you. We're going to work on that on Wednesday and Thursday on your block day. So take a look at that stuff, and if you have questions, which you should, then you can reserve them for Wednesday when we start going over this more easily. The thing is, now I don't have to do things such as spit out these theorems immediately. Okay? And I also don't have to go through this division process. I want you to have these and keep these in mind. And if you don't remember them, well, you will have to do division to figure it out. Otherwise, here are your difference in sum of two cubes, etc., etc.